So for the first one, okay, y is not directly proportional to x as it is not a straight line graph. Then for the other one, y is directly proportional to x as it is a straight line graph passing through the origin. Yes? Yes? Oh, you haven't finished copying? So the one on the left, it is not directly proportional because it's not a straight line. On the other one, it is directly proportional because it is a straight line and it passes through the origin. So that's all we require to determine whether they are directly proportional or not. So let me give you some examples. You tell me whether it is directly proportional or not. I'll just draw some graphs. Okay, is this directly proportional? So on y, this being x. Directly proportional? Yes, okay. How about now? Okay, this being a straight line. But it is steeper. Is it still directly proportional? Okay, yes it is. How about if I make it very gentle like this, and this is my x-axis. Is it directly proportional? Yes? Okay. How about now? Directly proportional? Why not? It doesn't pass through the origin, so it is not directly proportional. Okay. Last example, how about this? Is it directly proportional? Yes or no? Why not? It's a curve, it doesn't pass through the origin. How about now? Is it directly proportional? No, why? Because it's a curve. Okay, good. So let's fill out the next two blanks. Describe the change in y when the value of x is doubled. So from our table of values, when x is doubled, see when x from 2 becomes 4, what happened to the change in y? Here, double, right? Double. Then over here, is it double? No, how is it increased? It is multiplied by how much? From 14 to 56 multiplied by how much? 4, yeah. So when one is doubled, the other is quadrupled. Okay, so when x is doubled, y is quadrupled. Q-U-A-D or U-P-L-E-D. Why is it that when x times 2, then y must times 4? Are you able to tell why? There's a clue over here lah. Times what? Times 4. Why is it times 4? Because of the square. Okay? 2 square you get 4. 4 square you get 16. Every time you so in this case, it is quadrupled. It is just multiplied by 4. Okay, then describe the change in y when the value of x is halved. When the value of x is halved. So now, let's go the other way. From 4 it became 2. So we divide by 2, right? So we say it is halved. So obviously the other way, this must be divided by 4. Okay, so we just put it down in words. When x is halved, y is divided by 4. Okay, so that's the relationship that we can see. Later on there will be more examples that allows us to explore it further. Can I move on to the next page? Okay, now area of a circle. Can you write down the equation for the area of a circle? A equals to pi r square. Okay, write it down. Pi r square. Where pi is obviously a constant and r is our radius. So, is A directly proportional to anything over here? Proportional to r square? Okay. It is directly proportional to r square. Yeah, you're right. So, for directly proportional, it must look like this. Y equals to k times of x. This is direct proportion. In this case, I've got A equals to pi r squared. Well, y is our A, x will be our r squared. So we say that in the first case, right, y is directly proportional to x. So in the second one, we say that A is directly proportional to r squared. Okay? Now let us fill in the others. Volume of a sphere. This is, now I'll give it to you, it is 4 over 3 pi r cubed, where r is the radius. Sphere is like a ball is a sphere. Okay? So can you tell me V? The volume is directly proportional to what? What is the answer over here? R cubed. Good. Because all these, they are constants. This is a constant. These are all constants. Our K. Okay? So volume of a cone, 1/3 pi r cubed. So A, the volume in this case, they used A again, is directly proportional to, sorry, 1/3 pi volume of, pi r square h, where r is the radius and h is the height. Okay, I made a mistake. Volume of cone 1/3 pi r square h. So A is directly proportional to r square h, yes. Because the radius of a cone can change. The height of a cone can also change. So it is dependent on these two things. Now, for each of the following equations, state the two variables that are directly proportional to each other and show your reason. I'll demonstrate for the first one. The two variables directly proportional to each other are y and, what do you think is the other one? X minus 2? No, there must be a square root. Square root x minus 2. So these are the two variables that are directly proportional to each other. How? Huh? Oh, this is just n. So y n. Okay, and how do we prove that two things are directly proportional? As long as I can write it in the form y equals to kx, something equals to k times of something else, it is directly proportional. Or if you can write y over x equals to k, where k is a constant, then I also can prove that it is they are directly proportional. So in this case, how should I prove that these two are directly proportional? Would you like to use y equal to kx or y over x equals to k? Okay, if you, in this case, what is the value of k? 5, yeah. You can state that y equals to k square root x minus 2, where k equals to 5, constant. So you have proven that it is directly proportional. Or you can do this, which I think is a bit easier. Square root x minus y divided by square root x minus 2 is actually equal to 5, which is a constant. Therefore, they are directly proportional. Do you think this is slightly easier? Slightly shorter lah. We don't have to write down, we don't have to introduce the k. Alright? So I'll show you the second one, part B, then you will be doing the rest yourself. Okay, how about this? You decide which one you want me to do for you. B, C, D, or E. Which one want me to do for you? C? C? Then you do the rest yourself, okay? Part C. The two variables that are directly proportional to each other are y squared and x cubed. So why are they directly proportional? Just take y squared divided by x cubed equals to 0.1, which is a constant. Therefore, they are directly proportional to each other. So how much time do you think you need for B, D, and E? 1 minute can? No lah, just divide only ma. 2 minutes. You have 2 minutes until 10:30. Part B. What are the two variables that are directly proportional to each other? We've got y and the cube root of p plus 1. Okay, these two are directly proportional. Why? Because when you take y divided by cube root of p plus 1, you get 1 over 5, which is a constant. Yes? Then let's take a look at part E. I leave part D to the last. Let's do part E first. The variables that are direct proportion will be y and 1 over x. Why? Because when I take y divided by 1 over x, I get 4, which is a constant again. Does anybody have anything creative for part D? Huh? What's the answer? Y and 2x minus 3 lah. Do you get it? Anybody wrote that? Why not? Why will it be -1? Okay, let's take a look at part D. I'm telling you that now the variables are y and 2x minus 3. So what do you think is the value of k? Why got 0? 1, yeah. Isn't 1 a constant? So y divided by 2x minus 3 equals to 1, which is a constant. Can, right? Actually, these are questions, right? There are different answers. There are more than one answers. Okay? For part D, I will now give you an alternative answer. I can manipulate 2x equals to y plus 3. Okay, or we can write y plus 3 equals to 2x. So my variables could be y plus 3 and x. So why is that so? Because y plus 3 over x equals to 2, which is a constant. Will these be tested? Very unlikely. But you just need to know that you can manipulate and you can get different answers. Different answers can be accepted as long as you can divide one by the other and you show me a constant. Can already. Okay? Okay, now we are ready to try O-level questions. And this is the approach. You need to listen to me carefully because the next thing I'm going to say is going to be useful for you all the way until your O-levels. It is the exact same thing that I tell the Sec 4 students. So Kason, are you listening? Right, first sentence, y is proportional to x power n. Understand this sentence? Can you understand this sentence? Okay, first thing you write down, y equals to kx power n. Write it down now. Whenever they tell you that something is proportional to something, you can always write down the equation where there is a scale factor. In this case, it is k. Alright? Then now they tell you, write down the power of n, this power over here, when y represents the area of a circle radius x. So what do you think the equation for area of circle is? For part 1, area equals to pi r squared, isn't it? But instead of area, we now have y. That's what the question is telling you. The area is represented by y equals to pi. What is the radius represented by? In the question, x. Okay, x squared, right? So now can you tell me the value of n? Is it very clear already what's the value of n? 2. N equals to 2. So n equals to 2. If the question asks you what is the value of k, what will you tell me? Pi. But they didn't ask you for pi. They didn't ask you for k. So ignore it. So this is the answer. Can? Now, part 2. Y is the time taken to travel a distance x, and it is at a constant speed. So examples of variables and constants. So constant we have, for example, 1. Give me some other examples of constants. 3. What else? Can it be fractions? Half, okay. Can it be negative numbers? Can? Okay, negative 1 over 100. Can it be like, for example, pi? Can. How about 0.8 recurring? Is it a constant? All these are constants, yes? Who flowing? Raise our hand. Constants? Okay, now variables. Variables will be the opposite of constants. Variables will be things that can change. For example, x, y. Give me more examples of variables. Okay, z. A. As long as I say A is not a constant, then it's a variable. It can be anything, right? How about half A? Is it a variable or constant? Variable or constant? Variable, right? Because A can change. A is a variable. Half of a variable is still a variable. Still can change. Okay? How about 3x? Is it a variable? Yes, because x is a variable. 3 times variable, still a variable. What about square root y? Is it a variable? Okay. What about square root y plus 2? Variable? Okay. How about 2 plus x? This whole thing. Is it a variable? Yes, it is. It is made of constant plus variable. But when you take a constant plus variable, then it can end up with any other answers, right? So it is still a variable. That is why you see on this left-hand side, there are so many possible variables. This is considered a variable. This is considered a variable. X cubed is also a variable. All these are variables. Does it help you understand better now? Yes or no? Who still needs help for this? This part. Okay? Now that you have understood variables, how do we determine whether two variables are directly proportional or not? They must have the form y equals to kx, where y is a variable, x is a variable. Now, y itself could simply be y, x could be x. But like I said, since all I need is variable, it could have been maybe x cubed equals to y, k square root y. Get it? These are still variable equal to constant times variable. As long as you have this, it is directly proportional. Okay so far? Then I can make it more complicated. Instead of square root y, it could have been y square root y plus 2. Still variable equals to number times variable. Yes? Okay. So for those who don't understand, you need to tell me which part you do not understand. You need me a specific question so that I can address your query. For those who don't understand. Got space over here. Y is directly proportional to x if I can write this y equals to kx, or y over x is equal to k, where k is constant. This is our guiding principle. It's the same thing as 1 apple costs 30 cents, 10 apple costs $3. It's the same idea. Direct proportion. So when I change this y, instead of having y, I change it to some other variable. Let's say we have y plus 3. Is y plus 3 a variable? Is y plus 3 a variable? Yes, it is. Then this must be y plus 3. Then this must be y plus 3. Mechanics okay with this part? Okay now? Alright, so y plus 3 is directly proportional to, instead of calling it x, let's say I say it is directly proportional to x squared. Then I must be able to prove that y plus 3 is equals to kx squared. Or y plus 3 over x squared equals to a constant. When I am able to write this, it means that they are directly proportional. Okay? This sentence implies this. And this implies this sentence. They are the same thing. Who has a better understanding right now compared to 5 minutes ago? Okay, who still needs clarification? Raise your hand. Don't be shy already. Who still needs clarification? Okay, on which part? Which part? Wait, which one? A, B, C or D? Okay, part C, do you need me to go through this one? Okay, hang on first. Now, I will come to part D later. Let's start with part A again. Who needs help with part A? Part B? Okay, so let's try part B. As long as I can write two variables, and I put the variable divided by the other variable, I get a constant, I can conclude that they are directly proportional. Okay? So here I've got variables. There are different variables. I have options are variable. It could be y. It could be p. It could be p plus 1. It could be cube root of p plus 1. It could be 5y. All these are possible variables. Agree? But there are only two variables. Okay, I can't say only. There are two variables that when divided by each other gives you a number, a constant. If I am able to find two variables such that when you divide by each other you get a constant, then I conclude that those two variables are directly proportional. Understand the logic flow? Okay. Suppose I choose y and p as my variables, because it is very natural for me to say, oh, the two variables are y and p because they are the two unknowns, right? If I take y and p, if I take y divided by p, will you get a constant? Will you get a constant? Yes, no, or maybe? Yes, no, or don't know? Huh? Yes, is it? Let's try. Don't know. Okay, let's find out. If I take y divided by p, let's try taking y divided by p. So y equals to cube root of p plus 1 over 5. I want to take y divided by p, so I need to extract the p out, isn't it? So I need to multiply both sides by 5 first. 5y equals to cube root of p plus 1. Then I need to get rid of the cube root. I need to cube both sides. So 1, 2, 5, that's 5 cubed. Y to the power 3 equals to p plus 1. Correct? Then I wanted y divided by p. How do you take y divided by p over here? In order to prove that y and p are directly proportional. Can you take y divided by p? Can or cannot? Cannot. If you try, you try divide by p on both sides. So you get 125 y cubed over p equals to 1 plus 1 over p. I still don't have my y over p. You get what I'm saying? There is no way that I can form y over p equals to constant from these two variables that I've chosen, y and p. However, if I were to choose other variables, for example, if I choose y and cube root of p plus 1, these are my variables. Let me take y divided by cube root of p plus 1. What do I have as the answer? What is the answer? You can do simple division. Come on. Is it 5 or 1 over 5? 1 over 5. Is this a constant? Yes, it is a constant. Therefore, y and cube root of p plus 1 are directly proportional. Can? Any further clarifications required for part B? Part B? None. Then can I have a show of hands who understands part B right now? Who understands part B now? Raise your hand if you understand. Because I'm worried when I saw many hands up just now. So please pay attention, respond to my question. Who is comfortable with part B right now? Richie, are you okay? Okay, put our hands. The rest of you come in. Variables. I have y. There is also x. There is 1 over x. There is 4 over x if you like. All these are variables. Am I right? So choose two variables such that when you take one variable, the other divided by the other variable, you get a constant. What would you like to choose? Choose two out of these four. Because all these four are the variables that I can think of. Choose any two of them. Y as well as, you want to try x? Okay, let's try y and x. Can you form y divided by x from these two? Can you? From the equation, see, you've got y equals to 4 over x, right? I want you to manipulate such that you get y over x equals to something. Can you do that? If you think you can, please tell me how. What's the next step? Divide by x. Okay, let's divide by x. Y over x equals to 4 over x squared, right? Yeah, I did manage to create y over x. But on the other side, is it a constant? It is still a variable. So are they directly proportional? No, they are not. So y and x are not directly proportional. Okay, so we cannot have them. Choose another two variables. Y and 1 over x. Okay, let's try y and 1 over x. When I take y divided by 1 over x, what do we have? Are you sure 1? Y divided by 1 over x is not 1. Okay, y divided by 1 over x is the same as y times x over 1, right? Which is y times x, which is, according to the equation, y times x is 4. Is this a variable or constant? 4. Is it a variable or constant? Constant. So the two variables are y and 1 over x. Get it? Any other clarifications required? Is there any other variable you want me to try? Yes or no? Some of you are, I'm sure you're thinking of some sneaky way to get two variables, which will always work for A, B, C, D, E. Later I tell you the answer. Okay, so for now, is this okay with you? Then let's go on to part D. This was our last one for this series. There are so many variables again. I've got y, I've got x, I've got 2x, I've got y plus 3, I've got 2x minus 3. So many options for variables, as long as you can manipulate them out. But there are limited variables that will result in a constant when you take one divided by the other. So give me an example. What do you think we should try? Y and 2x minus 3. Okay, let's try y with 2x minus 3. If these two are my variables, then y divided by 2x minus 3, what do I have? 1. Is it a variable or constant? So, are these two acceptable as my variables that are directly proportional? Yes. So, we've got y and 2x minus 3. They are my variables. Now I'm telling you that there are more than one answers. Using this approach, right? Can you tell me the answer for an alternative answer for part A? An alternative answer for part A. Variables. Okay, let me tell you they are y and 5 root x minus 2. Can or not? Does this work? What is y divided by 5 square root x minus 2? 1. So they are directly proportional, right? Okay, let's try the next one. So this is my cheat method. The two variables are y and cube root of p plus 1 over 5. Can or not? Cannot. Y still get 1? Is it a constant? Yeah lah. So this is an alternative answer. How about this one? Y square and 0.1 x cubed. They are directly proportional, right? Because when I take one divided by the other, what do I have? Is it a constant or variable? Constant. So y square over 0.1 x cubed is constant. Therefore, does it make sense for me to set this type of question? Because everybody will get correct, right? Everybody will just divide without thinking too much. Am I right? Then everybody will get the constant of 1. So no point for this type of question to be set. Okay? Rather, the more common types of question, like what we will see in the O levels, is this type. Y is proportional to x power n. When they do not specify, it is implied. It is implied that it is directly when they do not specify. Alright? So y equals to k times of x to the power of n. Okay so far? So part 1, I think you can understand. Were you able to understand part 1? What about part 2? Part 2, no. Okay, never mind. Let me explain. It is a question on time, distance, and speed. For constant speed, we use this in our primary school, isn't it? Distance divided by time gives you speed. So now they want you to express y in terms of everything else. And they say that y is the time taken. So time equals to distance divided by speed. Okay, over here, time equals to distance divided by speed. All agree that? Okay? So time is given by y. In the question, they say that time is y. So replace it. Y equals to distance is x divided by speed. Am I right? Is this portion okay? Who is not okay with this part? You must raise your hand and let me know now. Oh, okay. The speed in the denominator, is it a constant or a variable? Constant or variable? Look at the question again. What did they say about the speed? Constant. The speed is constant. So this denominator over here is a constant, which means that I can write my equation like this. Y equals to 1 over speed times x. Yes? This thing over here, is it a constant or a variable? Constant or variable? Constant. 1 divided by a constant is still a constant, right? It's like 1 divided by 5. It is always equal to 0.2. It can't be anything else. It is a constant. So now, I have expressed it in the form of y equals to a constant times x. Is it of the same form as this in red? Do they have the same form? Yes, right? Okay. What is the value of k? 1 over speed. Good. What is the value of n? Is value of n? 1. You're right. It's 1. So n equals to 1. Right? X to the power 1 is simply x. Understand how this works? Which part don't understand? Are you okay this so far? Like this, okay? Then we compare. Let's compare with colors. Y and Y. Same? Same. K and this 1 over speed. Same? Same? Yeah, same. Therefore, x also same, right? Then the last one, our n over here at the top must be equal to power over here. What is that invisible power over there? 1. It is 1. There is a 1 over here. Therefore, n is equal to 1. Alright? I hope this clears up your doubts. Because things are going to get slightly more complicated now. Are you ready? Okay. Everybody, read exercise 9, first sentence. Read it together. Y is... Okay, stop. What can you write from this? Y equals to kx squared. Very good. This is what you must write already. Easy so far? Oh, earlier on there was an error in the answer. So this one, that's why I cancelled it off. They put -1. It should have been 1. Okay? So back to exercise 9. Y equals to kx squared. Do you have any clarifications required for this equation? No? Really understand it fully? Okay. Now the next sentence. X is increased by 100%. X is increased by 100%. That means there is an original value of x as a new value of x. Agree? All agree? Okay. What I'm going to write down, you don't have to write down. I'm just going to write down some notes at the side. Original. Okay, let's put it this way. Original. Original y equals to k times of original x with a square. Agree? Then I've got another one. The new y is equal to k times of x new with a square. Do you agree with these two, red and green? Do you agree with them? Can? The values of k over there, are they the same? Are these two k's the same? Yes, they are. So let me use black color to indicate that I'm talking about the same thing. It is the same constant. Okay? Now, x is increased by 100%. The original value of x versus the new value of x. Are you able to express the new value of x in terms of the old value of x? You understand what I'm saying? Suppose the old value of x is 10. What is the new value of x? If the old value of x is 1, what is the new value of x? So you understand how that works? Okay? So the new x over here is actually equals to 2 times of x original, right? Agree so far? Okay, then the new y is supposed to be equal to k times of x new squared, right? But now can I replace the x new with 2 times of the x original? Okay, so I'm going to do a replacement now. Instead of x new, it is going to be 2x original. Okay? So this is now become 2 times of, let me put it in red, x original. Okay so far? Okay, then I still need to square them, right? This square over here belongs to the 2x original, isn't it? Okay, let me expand now. This equals to k 2x squared. What do I get? 4 times x original. Okay so far? Are you okay so far? Okay, this is equal to 4k x, sorry, there's a square here, original with a square. Don't need to copy down, I just need to understand first. Agree so far? Who is lost already? Anybody lost? Okay, now we need to compare this. Kx squared original. Do you see it appear in my new y? Do you see kx squared original appear in my new y? You see it, right? Isn't it over here? Right? So I can replace that with equals to 4y original. Agree? Are they the same thing? What does this mean? You see, originally the question says that y equals to kx squared, right? Then what happened to the value of x? What happened to the value of x? Increased by 100% means it doubled. This means double. Am I right? When x double, did y double? Did y double? Look at the new y versus the original y. When x doubled, did y double? Didn't double. It was how many times? 4 times. Where did the 4 come from? Because of the square. You see, originally it was x squared, right? Instead of x original, it became x new. But x new is actually 2 times of x original. Because it is 2 times of x original and I square the whole thing, there's a bracket over here with a square. The 2 was also squared to become 4. Then the x original we square it to become x squared original. Therefore, when I manipulate, I actually see that it's actually 4 times of my original y. It is 4 times of my original y. Okay, so this is an example that shows you, in this case, y is directly proportional to x squared, but y is not directly proportional to x. Listen up, there's a difference between y is directly proportional to x squared versus y is directly proportional to x, which all of you are comfortable with. But this time it's y proportional to x squared. Okay? So the difference is that when we say y is directly proportional to x, when x double, y should double. If it is directly proportional to x. When x triples, y must triple. But today, we have y directly proportional to x squared. So when x double, y must quadruple, which is 2 square times. So now, what happens when x is tripled? What happens to y? Is it 6 times or 9 times? 9 times. It is 9 times. Because I'm not going to work it out for you. Okay, class. Stop talking. Class. Hey. Now, if x is tripled, this would have been 3x original, right? Then the next step, when I square it, 3 squared, this will become 9. So it will end up being 9 times. Okay? Now, how do we present our work? this is where you can start copying. And whatever I just written on the right side, right? Yeah, it works as a presentation, but you may find it a bit more tedious. So there are slightly easier ways for presenting. So we say that original y equals to kx squared. Okay, what this means is that the original y equals to k times of original x squared. Then new y equals to, are you ready for this? New y. New y equals to, is it the same k? Because this is my original equation, right? Let's see, from our first sentence we say that y equals to kx squared. So originally, it must be y equals to kx squared. Now the new one is y equals to, must still be k, right? And the k doesn't change. Let's leave it there. Equals to k. Now, I want to write x squared. But x is now changed. What did x become? What did x become? 2x. 2x with a bracket squared. You understand? Is there a difference between this versus y equals to k 2x squared? Is there a difference? Yes, there is a difference. Do you understand why this is wrong and this is correct? Because this square over here belongs to my x. When my x doubled, when my x becomes 2x, the square still belongs to the entire thing. Doesn't just belong to the x. Understand? Okay, so removing this. So now the new y equals to k times of 2x squared, and you can expand this normally, k times 4x squared. Okay, which is actually 4 times of kx squared. Then we see that actually kx squared is my original y, isn't it? So this is 4 times of the original y. Alright? So we say that the percentage increase. Okay, revision. Percentage increase. What is the formula? What's the formula for percentage increase? Yeah, something minus something divided by something times 100%. Final, initial. Okay, so final we have 4y, right, with the original y lah. 4 original y minus initially how many y? 1, it's just 1 y. Divided by initial how many? Y again. Times 100%. 4y minus y, 3y. 3y divided by y, 3. 3 times 100%, 300%. Have I made this clear? Sure tested, Sure tested. Put a star. Put 2 stars. Put 3 stars. Okay. Done? Okay, next. B equals to k times new y x cubed. Can? The k is constant. K doesn't change. Then they say that it is known that y equals to 24 for a particular value of x. For a certain value of x, y is equal to 24. Does this equation make sense to you? Original? Do you know the value of x? Do you know the value of k? You don't know. Do you get to guess and choose values you want? You shouldn't be guessing. There is no reason to guess also. I just know that there is a certain value of x, certain value of k, such that kx cubed will give me 24. Okay? Then they say, find the value of y when the value of x is half. Okay, find the value of y when the value of x is halved. If the question was y is proportional to x. If the question is y is proportional to x, then they tell you that y equals to kx lah, which is equal to 24. When x is halved, what do you think y will become? For my question in red, directly proportional y and x. If x is halved, then y must be halved. Then what will our answer be? 12, right? It will be 12. Is there a need to find the value of x? Is there a need to find the value of k? No need. But today, it is not directly proportional to x. It is directly proportional to x cubed. But we will still use the same approach. So, next line. New. The new y. Okay, write that down. New y equals to. What is the next thing that I can write? No, not half yet. Not yet. K, yes. Is there anything to change for k? No, because k is a constant. You need to keep reminding yourself that k is a constant. Then now I've got x cubed, right? Should I leave it as x cubed? Then what should it become? Half x cubed. Is it like this? Half x cubed. Like this? Where should the cube be? Outside the bracket. Okay? So let us simplify. We get k 1 over 8x cubed. Agree? Half to the power of 3 is 1 over 8. So this is 1 over 8 kx cubed. Okay so far? Okay, now I want a value of y. I want a new value of y. What is it? What is the new value of y? 1 over 8 times 24. Why did 24 appear again? Yeah, kx cubed is 24. That is how I get the answer of 3.